Hello. So we're learning Coulomb's law and calculations under it. Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. What is this guy saying? He's saying that if you have a charge A and you have another charge B, then you have third charge C, then another one D. It said the force of attraction between these 2 point charges is directly proportional to the product of the charges. That is, if we have this charge, what's the SI unit for charge? It's coulomb. So we have 10 coulomb, and B we have let me say 20 coulomb. So he said the force pulling them together, the force of attraction between these 2 point charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. That is, if you increase these charges, it will make them to come closer. Do you get what I'm saying? Let me explain what directly proportional mean. Directly proportional, when you put it in mathematical form, F, which is stand for force, in this case force of attraction, F is directly proportional to the product. Let's take this one as A and B. A then B is directly proportional to the product of the two charges A and B. Directly proportional simply means that when one increases, the other one will also increase. So if you increase the charges, the force will also increase. If you increase the product of the two charges, the force will also increase. That's the force pulling them together will also increase. When the charges is I, the force pulling them together will also increase. But look at the other one. It said the force of attraction or repulsion between the 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. There's a distance between this and this. This is the distance. Let's take it as D. So Coulomb said that the force of attraction in this case is inversely proportional to the square of the distance between them. So distance square. So to represent distance, it's over D. Sorry. To represent inversely proportional sign, use over D. It's like F1 over D. That's how you present inverse proportional. So I'm just adding it directly to this equation. So force is inversely proportional to the distance. Look at this. When you increase the distance, the force will what? Will decrease. That means if they are very far apart, there'll be little attraction between them. There'll be little force. If the distance is very high, the force between them will low. But if the force is high, it simply means that the distance between them is very small. So that's what inversely proportional means. I hope you get this. So the same apply for repulsion. The force of repulsion between 2 point charges is directly proportional to their to the product of the charges and inversely proportional to the square of the distance between them. So now let's go to the next question. Now let's continue. So the symbol for a charge is capital letter Q. Yeah, symbol for charge is capital letter Q. So the Coulomb's law is represented with this mathematical representation. F, which is force, is directly proportional to the, let's say Q1, to the product of the charge Q1 and let's say Q2, and the distance between them, let's say, is R square. It can be D, whatever you want to represent it as. So Coulomb's law is the force of attraction or repulsion between 2 point charges is directly proportional. This is the proportionality sign to the product of the two charges and inversely proportional to the square of the distance between them. So Q1, Q2, force of attraction or repulsion is the distance between them, then square. Can be R or it can be D, whatever way you want to represent it. So we want to remove this proportionality sign. In mathematics, to remove proportionality sign, you introduce equal to and K. So wherever I see this proportionality sign, I will introduce equal to and K. So now give us F equal to K Q1 Q2 over R square. So this is Coulomb's equation. The force is of attraction or repulsion is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. Now, as stated before now, F, which is the force of interaction or the force of attraction or repulsion, is equal to K, which is the proportionality sign, the constant of proportionality, sorry, Q charges and the distance between them. So F stands for force of interaction, which can be attraction or repulsion. Take note, it can be both. It can be both. And Q1, Q2 are charges. R is distance between charges, the two charges. While K is a constant of proportionality. Take note, it's a constant. So its value is something that's already defined. And that the value is 9 times 10 to the power of 9 Newton meter square per Coulomb square. For the value, I repeat, is 9 times 10 to the power of 9 Newton meter square per Coulomb square. Do you know how we got this Newton meter square per Coulomb square as the unit for the constant of proportionality? This is how. It's just by making this K the subject of formula. When you do that, F is equal to K Q1 Q2. So just these two multiply each other to give you K Q1 Q2 equal to F R square. So when you make K the subject, K will not be equal to F R square all over K Q1 Q2. F, sorry, this K is not supposed to be here again. So K is equal to F R square over Q1 Q2. What's the unit for F force is what? Newton. The unit for distance is what? Meter square. And Q1 Q2 they have what? Coulomb. So it's Coulomb times Coulomb. That'll give you Coulomb square, give you Newton meter square per Coulomb square. That is how we got the unit for this constant of proportionality. Now let's go over to solve.